Welcome back everyone, Patrick here, and in this particular video what we're going to do is we're going to use multiple methods to find an expanded expression for this area over here. Now we've gone through questions like this before, and so when I'm doing this I'm assuming you've gone through those previous videos in the previous sections of these types of questions. Here it's going to be the exact same thing, same process. It's just now there's going to be a couple of special products within these different methods, but the process is the same. And if you remember, the way we were doing this was we were taking a shape like this and we were splitting it up into multiple shapes that we can work with. And so I'm going to show you a couple of different ways to do it. One way is, let's maybe create two shapes like that. So notice we'll have this rectangle over here, and then we'll have another rectangle right here. Now notice for this rectangle, we already have the dimensions. We have the 12 and then the 6 for the length and width, right? This x here represents this whole length. So let me put that on the side a little bit more. It represents this whole length here, but we don't need that whole length for this area over here. For this area, we just need this width, this length over here. So what we'll have is the total area equaling the area of this first rectangle, which is going to be 12 times 6. Now, what about this second rectangle? How are we going to get an expression for that area? Well, this one's going to be a little bit more tricky. We do have the length already. This entire length here is x plus 6. But we don't have this width over here, or this width. Both of them are the same thing, right? So we're going to have to get that right there. And how can we do that? Well, notice we can get it because we know this entire length is x, and we know that this length here is going to be 6. From here to here is 6. And then the entire thing is x. So if we wanted to get this, what we can do is we could just take that entire length of x and subtract this length of 6, and that would give us x minus 6 for this length right there. Right? So this here is going to be x minus 6. So we had to kind of combine this information and this information in order to get that x minus 6. And now notice we have the length, we have the width, so it's going to be the area of that second rectangle, of that top rectangle, is going to be x plus 6 times x minus 6. So that's where that special product is coming in there, right? That's a difference of squares if you notice. So now we just have to simplify 72, expand this, that's going to be x squared minus 6x plus 6x minus 36. The middle terms cancel out, so we got 72 plus x squared minus 36. 72 minus 36, that simplifies to 36. Let's put the variable first. Put in a nicer format, so x squared plus 36 ends up being the expression for the area. All right, so let's see if we can maybe do another method and get the same expression of x squared plus 36. That's the answer there. So what's another way we can do this? So this is one way to split it up. Well, notice we can also split it up like this over here. So we'd have this rectangle and then this rectangle over here. Now for this particular rectangle, notice that we already have, let me erase some stuff here so you're not getting confused. Notice here we got the width of 12, and then notice here we have this length of x right here. So this area is already done. That is 12 times x right there, right? 12 times x. But then what about this one over here? Notice for this one, we do have an x minus 6, right? That's this over here, same thing here. That's going to be x minus 6. We already got that from the previous method when we got this portion, this portion, this portion, this portion, all of those are the same thing. So what's missing now is to just get this length over here, or this length. Notice we don't have that. We have this entire length, which is the x plus 6. So let me put that a little higher. So we got x plus 6 for this entire length. Okay, but we don't need that entire length. We just need this length over here. So how can we get it? Well, we can get it because notice that we got 12 over here for this length. So this length is 12, which means this length over here is 12 as well. So if we wanted to get this remaining length, all we have to do is take the total, which is x plus 6, and subtract this 12 over here. And then notice that if we simplify that, that's going to give us x minus 6, right? Positive 6 minus 12 gives us negative 6. And so that's the expression for this length right there. So this, it's actually a square because notice that we have the same side length, right? The length and the width are not different. It's x minus 6, x minus 6. So this is actually a square that we end up getting here. So we got this rectangle, 12x. So 12x is that area. And then we have this square over here. So it's actually just going to be plus x minus 6. You could rewrite it as squared. And then I am going to expand this because we need an expanded expression. So the 12x can't simplify that, but over here, x times x squared, x times negative 6 is minus 6x. Minus 6 times x is minus 6x, and then minus 6 times minus 6 gives us positive 36, like that, right? So notice that this here, this is a perfect square trinomial that we end up getting, right? We're squaring a binomial versus the other method, we were doing a difference of squares. This here is squaring a binomial expression. But let's see what we end up getting when we simplify. So notice the only like terms here, 12x minus 6x minus 6x. What do those net out to? 0. 12 minus 6 minus 6 ends up being 0. So there's no x term. It's like 0x, and you don't have to write that. We end up with x squared plus 36. So notice we end up getting that exact same expression for the total area as we got before. Okay, so that is another way to do it. And then the final way that I will go through, and I went through this in the previous videos, is what you can do is if you get something like this, you can actually look at it as a large area. So we could take this entire area over here, right? Which is going to be what? It's going to be x plus 6, this entire length, times x, right? We know this entire length is x. We know this entire length is x plus 6, or this entire length is x plus 6. So we could take that large total, which is going to be x times x plus 6, and we could subtract this empty area right there. And notice that we have the dimensions of this empty area. This length is 6. Notice that this length, which is the same as this length, which is the same as this one, is x minus 6. We got that from the previous method when we were dealing with this square over here. This, and this are the exact same thing. So if we're just looking at this empty area, it would be 6 times x minus 6. And we got to subtract that empty area from the large area to get this remaining area that we're looking for. So we're going to be subtracting 6 times x minus 6. And so what would happen here? X squared plus 6x minus 6x plus 36. After we distribute, notice these are like terms, cancel out, we end up with x squared plus 36. Exact same expression. Okay, so multiple methods to do this. This method didn't have any special products, so I saved it for last, but it probably had the least algebra of all the other methods. So whichever way you do it, x squared plus 36 is the final answer.